Hi everyone, myself Gksr from EC Department of Sri Venkateswara College of Engineering, Svce, Bangalore. Today I am going to discuss about the uh, contents introduction, system discrimination, that is onboard controller, the real-time kernel, sensors and actuated wireless communication systems, the control applications such as sensor data capture, actuators control real-time issues, power management such as dynamic voltage scheduling, peripheral input output, kernel support, and conclusion in this presentation. Introduction. The paper performs both autonomous navigation and mission related activities, and it allows easy interchange of sensors and for adapting the vehicle to different monitoring application. The aircraft model has two flight modes, manual and autonomous. Manual mode, the application is implemented by the real-time kernel with limited onboard sources. System description is given in the slide, PPT slide. Uh, we can see three gyroscopes, two pressure sensors, MMC, inclinometer, three-axis accelerometer, microcontrollers, cameras, GPS, wireless communication modules, battery packs, temperature sensors, and all in the system description given in the slide. The system performs sensory acquisition, uses such data to trigger the motors for speed, direction control during autonomous flight, control the power consumption of external devices, send the relevant sensor information to the ground stations. Onboard controller, a microchip, the ESPIC 30F6014 microcontroller. It integrates the central features of microcontroller unit with the digital signal processor. It is the 16-bit microcontroller with a maximum processing power of 30 MIPS, program memory space of 144 kilobytes, data memory space of 8 kilobytes, and non-volatile data EEPROM of 4 kilobytes. The MCU power management system allows two modes, idle and sleep. The idle mode disables the CPU. In the sleep mode, both the CPU and the system clock source are disabled. The real-time kernel, uh, ERIKA, embedded real-time kernel architecture, enterprise real-time kernel T, uh, configurable both in terms of services and kernel objectives such as task resources and events, achieving a minimal memory footprint of 2 kilobytes, available for a wide variety of 8, 16 and 32-bit CPUs, two layers, HAL and kernel layer, sensors and actuators. The microcontroller is connected to several sensors, three gyroscopes as we saw in that picture, one for each axis, two pressure sensors and inclinometer, MMC, multimedia card, the memory module, digital three accelerometers, temperature sensor, GPS module, wireless communication module, video camera and infrared camera. The microcontroller integrates the buses, wireless communication system, the data communication module to exchange information with the ground station, two independent video channels for the normal and infrared cameras, the receiver for manual control normal operations, a dedicated channel to select the manual autonomous navigation mode. The solution adopted the control separates the manual control system for the microcontroller. The control application uh, Block diagram is given here. That absolute set point is given. Trajectory definition is given for guidance algorithm. It is then followed by the uh, control and stabilization actuators, sensor data, filtering, navigation algorithm, and then it's a circular process. Mm, Moving on to the next slide. Uh, the UAV has 6 degrees of freedom, 3 liners and 3 rotational, sufficiently high frequency, 80 Hz control. Mm, Power management. All the systems are powered by two different battery packs. One for the receiver, the manual auto selection, custom board, the throttle motor and flap servo motors. The second feeds sensors and control board monitoring based on Texas Instrumental BQ27200 chip LI on and LI pole. Dynamic voltage scheduling to save energy by alternating two discrete clock frequencies, a PWM signal to obtain the optimal clock value, to calculate different speeds, a combination of those two. mm, Kernel support to get the maximum and minimum power level, to get the power level required by the running ready or ideal task. By the conclusion, the paper describes a real-time control system for the autonomous flight of model aircraft. The description focuses on all the relevant architecture components, the hardware platform and software platform. Thank you everyone for the opportunity given.